Hello, welcome back. This is for the homework 5 exercise 2. We are firstly given that the joint density function of x and y is equals to this, and y is larger than 1. X is larger than that and smaller than y here. So for the first question, it led us to draw the non-zero definition region of fxy. So for this question, it's really simple here. We are given the x here, that is the region of x, so we could just draw this is the here, this line is y equals to that is that is that is same, x equals to 1 over y, and the other line is x equals to y. X equals to y, and here we are also given that y is larger than and equals to 1. So the intersection of this line here, that should be 1, 1 here. So the definition region of this density function is here, right? Here x is let me change the color here, maybe blue. X is larger than here, and it is smaller than y here, and y is also larger than or equals to 1. So that is this region. For the second question, we are going to find a, so that the joint density function is a valid function here. So we could use definition that that should be 2, right? dx dy equals to 1. So that is the definition, and we could use that to solve a. So here, let me so from the previous figure here, we could notice that y is larger than 1. So for the upper bound and lower bound of y, we could write like this, and for the x, that is larger than 1 over y and smaller than y, and for this area it is equals to 1 over a times with y with the power of 2 times x. Here is the x, right? So firstly, we are going to solve here. That is, we could just, you could write my answer here. Here we solve this part. We need to firstly we solve the integration of x, so we get that, and we get that here. Here we define a new variable that is lambda equals to ln y, since it's better to solve to use the simple way to express this integration. So we take it back to the formula, to the expression here, we get that, and we take the e with the power of lambda out of the derivative, and we get the lambda, and here the derivative of this is e with the power of lambda, and then there is 2 lambda, 1 lambda here, so we only get 1 e with the power of minus lambda here. And so by in this step, we use the how should I say, the I don't know how to say that in English, but we know the formula, right? So this is equals to this minus this minus this one, but here there is a minus here, and that is why out of this parenthesis here is plus, right? I can write the formula here, that is uv minus u dv equals to here v du, right? This is our the formula for this step. By this step we get 2 over a equals to 1, so a is equals to 2. For the third question, we need to find the marginal density function of fx and fy. So by the definition, the density function of x is equals to the integration of the drawing density function, but with the derivative of y here, dy. So we need to express, since this is dy, so we need to use x to express the upper bound and lower bound of this density function here. So going back to the figure, we could so this is our shaded area. We could divide it into 2 parts, that is let me use other color, maybe green. So we could divide it by the left part here and the right part. So we could discuss by these 2 situations. So when x is larger than 0 and smaller than 1, that is for the left part here. Let me change it to the right color. So at this time, y, the lower bound of y is 1 over x, right? That is here. This is the minimum value of y, and to the infinity, that is so that's why we write this expression here, and this is equals to 1 over 2. And for the right part, that is x is larger than 1, so that is this line to the infinity here. So the lower bound is x and to the infinity, so we could get that is 1 over 2 times x with the power of 2, and based on this we could simply draw the figure of fx. For the density function of y, the definition is similar, but at this time we need to use dx. So also we can go back to figure here. So since we are dx, so we are gonna to express x using y for the lower bound and upper bound. So for the area of x, that is here here to here, so that is lower bound is, that's why it's 1 over y, and the upper bound is y. So solving this, we could get result here, but we are given that y is larger than 1. That is why we don't have this part of the figure. For the last question, it asks us to verify those 2 marginal density functions are valid. So we could solve this simply using the definition of marginal function, that is the integration of the marginal function is equals to 1. So we just calculate this, and we to judge if it is equals to 1. If it equals to 1, it is valid. So for the x, we could also divide it into two parts, that is, well, from x is from 0 to 1, that is equals to 1 over 2 here, and when x is larger than 1, it is equals to 1 over 2 with the power 2 times x with the power of 2. By solving this expression, we could get it is equals to 1. So for x, it is a valid density function. For y, we also use the definition of this, and we could get the result of the integral is equals to 1 as well. So at this step, we could verify that fx and fy are valid density function. So thank you.